welcome to this deep dive. So you asked about software testing, specifically the details around unit and integration testing. We've got some material, and we're going to break it down.
Yeah, absolutely. We're aiming to clarify how these two, well, fundamental testing methods help make sure software actually works.
Great. So maybe start with the basics. What is unit testing?
Okay. Unit testing is like checking individual components, small pieces of code. You want to make sure each little part functions correctly all by itself. Think of it like checking each ingredient before you cook.
Okay, ingredient check. And integration testing.
That's more like tasting the final dish. It's about seeing how those individual parts, those units work together. Do they interact correctly? Do they, integrate?
Got it. Individual versus the combined whole. So let's dig into the differences. What about their main purpose?
Well, the main goal for unit testing is strictly verifying the correctness of those small individual units, modules, components, functions, whatever you call them, just making sure each one is solid.
Right, ready to be used.
Exactly. Integration testing, on the other hand, its purpose is to check the connections, the interfaces and interactions between those units. Do they play nicely together as a group?
Okay, so it sounds like unit testing is much more focused scope-wise.
Definitely. Very narrow scope for unit tests, just one piece at a time, in isolation. Integration testing broadens that scope. You combine several modules and test them as a group.
And where do these fit in the development process? When do you actually do them?
Good question. Unit testing, ideally you can do it pretty much any time during development.
Yeah.
And the earlier the better, right? Finding bugs early saves a lot of hassle and cost.
Makes sense. Cheaper to fix early.
For sure. Integration testing, that usually happens after you've done the unit test for the components involved, but before you do full system testing. It's kind of a bridge.
So a sequence, unit, then integration, then system.
Right.
Who typically performs these tests?
Generally, yeah, the developer who wrote the code does the unit testing. They understand that specific piece best. Integration testing, that's often handled by a dedicated testing team, or maybe different developers working together, people who have a, let's say, broader view of how things connect.
Right. Now, what about finding the actual errors? Is one easier than the other?
Generally, yes. Errors in unit tests are often easier to find. Because you're looking at such a small, isolated piece of code, the problem is usually right there.
Contained.
Exactly. With integration tests, finding the root cause can be, well, trickier. The error might be in module A, module B, or just the way they're communicating. It could stem from that interaction.
Yeah, I can see that. We saw mentions of white box versus black box testing. How does that fit in?
That's a good analogy they use. Unit testing is often considered white box because the tester, usually the developer, knows the internal code structure. They can see inside the box. Integration testing leans more towards black box. The tester is more focused on the inputs and outputs between modules, without necessarily needing to know the detailed internal workings of each one. They're testing the connections from the outside, mostly.
Interesting distinction. What about things outside the code itself, like external databases or services?
Right. Unit tests typically don't verify if your code works correctly with those external dependencies. They often use mocks or stubs to isolate the unit.
Okay, so they pretend those external things work.
Kind of, yeah. Integration tests, however, are specifically meant to verify that your code does work with those real external dependencies. That's a key part of checking the integration.
That seems pretty crucial for actual applications.
Oh, absolutely vital.
And I think I saw a note about maintenance cost.
Yeah, that's a practical point. Unit tests generally have a lower maintenance cost. They're small, isolated, so changes elsewhere are less likely to break them.
Makes sense.
Integration tests can be more expensive to maintain. Because they test the connections, a change in any of the involved modules or the interface between them might require the test to be updated.
Okay. And quickly, the sources mentioned starting points, module specification, and interface specification.
Right. Unit testing really starts from the module specification, the requirements for that single piece of code. What should it do? Integration testing starts from the interface specification. How are these different pieces designed to talk to each other?
So the blueprint for the part versus the blueprint for the connections.
You got it.
And there were mentions of different approaches, like bottom-up and top-down for integration.
Yeah.
Briefly.
Yeah, those are just strategies for how you conduct integration testing. Bottom-up means testing the lower-level modules together first and working your way up. Top-down starts with the higher-level modules and works down, maybe using stubs for the lower ones initially. Just different ways to tackle it.
Okay, cool. So wrapping this up, unit testing is making sure each musician can play their instrument correctly and in tune. And Integration testing is making sure the whole orchestra can play the symphony together, harmoniously.
That's a fantastic analogy. Yeah. The big takeaway really is you need both. You can't just have one.
Yeah.
Well-tested individual parts and proof that they work together correctly, that's how you build reliable software.
It really drives home that layered approach.
Yeah.
It makes you think, doesn't it? How many complex systems rely on both individual part quality and seamless integration? What happens in, say, manufacturing or even biology when perfectly good components just don't fit or work together? Something to chew on. Thanks for breaking that down.